students, today let us learn chemical reactions and equations, your first chapter in class 10 science subject. You see, in our surroundings, we can see the matter is actually transforming before our own eyes. This chapter explores how substances change entirely new materials through chemical reactions. So, in chemical reactions, lot of new substances have been produced. So, let's see how this is actually works. So what is a chemical reaction? So chemical reaction here, one or two substances, two or three substances actually undergo transformation to create new substances. They are entirely different properties. Here what happens is breaking and forming of atomic bonds takes place. So here original substances like reactants are there, they react each other and they disappear as their atoms rearrange to form completely new materials. Those are called as products with unique characteristics. The whole process involves energy changes like often releasing or absorbing heat, light or other forms of energy. Here bond breaking takes place, chemical bonds between atoms are broken and atom rearrangements also takes place and new bond formation happens. You can see in the slide, these are the examples like rusting iron, burning candle, formation of curd, digestion, photosynthesis and all that. So in this slide, you can see the difference between physical changes and chemical changes. Physical changes are reversible in nature, chemical changes are irreversible in nature. No new substances are formed in physical changes. Here, new substances are formed. This is a temporary state, physical changes. This is a permanent state, alterations are there. Here, melting ice, dissolving sugar, crushing paper, they are the examples for physical change. Burning magnesium, cooking eggs, fermentation, these are all the examples for chemical changes. So you can see, you can quote many examples for chemical changes. So in exothermic reactions, what happens? Energy are released like energy or light. While if the energy or light is absorbed, then that is called as endothermic reactions. So why do we actually use chemical equations? When you want to express chemical reactions, you need to express, it will be easy and precise and concise, and it is a universal language to represent chemical reactions in the form of chemical equations. So that gives a concise and precise way to represent. So these are the three types, like word equation is there, skeletal equations is there, balanced equations is there. Magnesium plus oxygen and gives a and they react each other and produces magnesium oxide is produced. If you are representing in words, that is called word equation. If you are representing through chemical symbols or formulae, that is called skeletal equation or chemical equation. So if you want to balance that chemical equation, then that is called balanced equation. Here you see 2 mg plus O2, 2 mgO. So we are actually balancing here. Whereas in the earlier in the skeletal equation, you can see that oxygen is not balanced. So hence in the right hand side, we coefficient 2 has been added here. So why we have to balance means law of conservation of mass. So because of this, matter cannot be created or destroyed in chemical reactions. The total mass of reactants must be equal to the total mass of products. So these fundamental principles ensures that we can predict quantities accurately, whether we are calculating how much product we will obtain from given reactants or determining how much starting material we need for a desired amount of product. Why we require to balance means we can find here. So balancing a chemical equation step-by-step approach. You can see methane reacts with oxygen resulting into or giving to carbon dioxide and water. Here carbon is balanced in both sides, but here hydrogen is not balanced. So 4 coefficient of 2 should be added in the right hand side. So to balance hydrogen, and to balance oxygen, right hand side left needs to be add coefficient 2. So here all perfectly you can see carbon is balanced, earlier it was balanced, hydrogen and oxygen also balanced here. So the one important tip you need to take care is you need to balance metals first, and then later you have to take oxygen and hydrogen. Now, one thing is you don't change the chemical formula of compounds, only adjust coefficients only, like we did in this example. So, informative equation, physical states and conditions. So, we represent each chemical substance into like solid. If it is solid, we represent in bracket like S. If it is liquid, in bracket we represent as L. Yeah, and if it is gas, we represent as G. Or in aqueous state, you represent as AQ. Complete equation example you can see here. So, if since iron is solid, we are mentioning it as S, water is liquid, and Fe3O4 is solid, and then hydrogen is gas. So, this equation tells us that solid iron reacts with liquid water when heated to produce solid iron oxide. Then this is also solid and hydrogen gas. So, this actually helps us to know the states of reactants and products. So types of chemical reactions, you can see there are many different types of chemical reactions. One is combination reaction, another is decomposition reaction, displacement reaction and double displacement reaction. So combination reaction is two or more reactants unite to form one product. Like here, calcium oxide reacts vigorously with water to produce slaked lime, releasing a large amount of heat. At the same time, one compound breaks down into two or more products. Decomposition means one compound breaks down and resulting into two or more products. Ferrous sulfate broken down into, you can see Fe2O3, SO2 and SO3. Displacement is one element displaces another from its compound. I have given one example here. Copper has been actually displaced here. And double displacement. Here one displacement takes place here double displacement. Two compounds exchange their constituent ions. So why classify reactions? Why you have to classify these reactions? So the reason is chemists, this classification helps chemists to understand the patterns, predict products and design synthetic pathways. Each reaction type has characteristic features that allows us to anticipate what will happen when different substances interact under various conditions. So for example, combustion reactions often involve both combination with oxygen and redox. Here we have mentioned redox process. Electron transfer takes place in redox. Understanding these overlapping patterns provide deeper insight into chemical behavior. So because of this we can understand the chemical behavior. So combination and decomposition reaction. Combination and decomposition reactions represents the opposite process. In combination, actually synthesis reaction, they synthesize, they add each other. So, but whereas in decomposition reaction, they break down into complex substances into simpler substances. Whereas in combination reaction, synthesis reactions, these processes create more complex substances and simpler ones. You can see example here. So magnesium and oxide, magnesium oxide here. Brilliant white light production, highly exothermic. Heat is released here. Here thermal decomposition, heat breaks down compounds here. You can see water formation, hydrogen plus oxygen, water forms, foundation of hydrogen fuel cells. So for combination reaction, water formation of water is a very simple example. Whereas in decomposition reaction, you can see thermal decomposition, electrolyte decomposition and photolytic decomposition. Light energy causes breakdown here. So because of light, uh, the water uses light and breaks down into H2O and oxygen. Here electricity splits into compounds. Here thermal decomposition, heat is actually used to break down into these compounds. So real world application, decomposition of hydrogen peroxide. When you fell down or when you have wound on your any body parts, doctor uses compounder uses hydrogen peroxide. So when hydrogen peroxide, that liquid is poured into your wound, You can see the hair bleaching takes place and wounds cleans. You can see the bubbling bubbles are, you can see the bubbles. This bubbling you see is oxygen gas is released. That is thermal decomposition of limestone produces lime for cement manufacturing also. And one best example is photosynthesis. So photosynthesis, what happens? Combines carbon dioxide and water combination. While cellular respiration breaks down glucose for energy decomposition. Understanding these patterns helps explain everything from industrial manufacturing to ecological to biological, industrial manufacturing to biological metabolism. So redox reactions, these are two are redox reactions. One is oxidation and reduction. So what do you mean by redox reactions? These are among the most important chemical processes on earth, covering everything from cellular respiration to battery technology. These reactions involve the transfer of electrons between substances, fundamentally changing the chemical nature. You can see in the oxidation, you see gain of oxygen elements. Oxygen element is gained. So here you can see magnesium and oxygen. Magnesium oxide. Here magnesium is oxidized. Magnesium is used oxygen actually. Gain of oxygen atoms. Loss of hydrogen atoms takes place. Loss of electrons takes place. Increase in oxidation number. These are the characteristics of oxidation. In reduction, loss of oxygen atoms takes place. But gain of hydrogen atoms, completely opposite to oxidation. Here loss of electrons in oxidation. In reduction, loss of gain of electrons. And increase in oxidation number, here decrease in oxidation number. An example is also given for copper oxide is reduced here to copper and oxygen. So understanding redox through examples. Let's examine, you can examine this reaction, zinc oxide plus carbon, zinc and carbon monoxide. In this metallurgical process, zinc oxide is reduced. It loses oxygen. Here you can see it loses oxygen. To form metallic zinc is formed and carbon monoxide is released. So carbon is oxidized here. It gains oxygen to form carbon monoxide. Remember, oxidation and reduction always occur simultaneously in redox of reactions. One substance cannot be oxidized without another being reduced. So one substance cannot be oxidized without another being reduced. While in the process of oxidation, so one another element will be reduced. This principle is captured in the mnemonic. You can easily remember by using this mnemonic OILRAG. Oxidation involves loss of electrons. Reduction involves gain of electron. You can see OIL means oxygen involves loss of electron. Here we have mentioned here loss of electrons. Here gain of electrons. Reduction is gain of electrons. Every redox reactions every day. In every day, you can see these are the redox reactions, right? Rusting of iron, cellular respiration, battery operation, photosynthesis, combustion processes. These are all redox reactions wherein the loss of oxygen atoms takes place here. Redox reactions are the foundation of energy production in living organisms and power generation in batteries. Understanding electron transfer helps explain how our bodies extract energy from food and how renewable energy technologies store and release power. You can see redox reactions are most important reactions. They are the foundation of energy production in living organisms, in human and also in even in plants also, and in power generation in batteries also. So we are coming to the last summary, why it matters, why these chemical reactions and chemical equations chapter is most important. These reactions form the very foundation of our existence. You can see the whole life in our whole surroundings. You can see always one or the other chemical reactions are taking place and the atoms are broken down and chemical bonds are changed and all that. and this drive every process that makes life possible. From the oxygen we breathe to the food we digest, chemistry surrounds us in countless fascinating ways. Here you can see life processes, industrial applications, and environmental impact. In life process, chemical equations, chemical reactions you can see like in photosynthesis in plants, digestion in animals. So these are the processes. In industrial applications, chemical reactions, power manufacturing, production of medicines, plastics. In many productions, in many industrial applications, we can see a lot of chemical reactions takes place. In environmental impact, understanding chemical reactions helps us to address environmental challenges like pollution control, renewable energy development, and climate change mitigation through improved chemical processes. So it's having an environmental impact also. So what are the key learning outcomes here? So we have learned how to balance the chemical equations and chemical how to classify these chemical reactions and identify the patterns and predict products and state symbols and conditions like which is in the chemical equations, which is solid and which is liquid and which is gas and which is aqueous state. Redox understanding, which is the most important one. So study tip for you, practice balancing equations daily and identify reaction types in everyday process. Chemistry becomes clearer when you see it in action around you. So explore chemistry in action. You can see in cooking, you can see chemistry, resting, photosynthesis, digestion. Even in breathing also you can see chemistry. So the journey of chemistry begins from this very first chapter, friends. So I hope you understood this simple concept. I tried my level best to make you to understand. Thank you so much.